little section for 4.2b where we're talking about the unit circle. Not that this is going to be the end of our talk of the unit circle, but it's the last time we're going to title it the unit circle. So yesterday in our notes and in our homework, we went through and we listed out those 6 trigonometric functions, right? So we're going to list them again today. So our trigonometric... Yesterday was the quiz. Oh, yesterday was the quiz. Thank you. Sorry. So in the last lesson we went over, so trigonometric functions. Do you guys ever get to the point where like the days just kind of start running together? I think that's where I am this week, right? So when we went through our trigonometric functions, we sat there and said the cosine of t was like our x values on our little unit circle, all right? And then we listed out the sine of t, and the sine of t is our y values. And then we listed the tangent of t. That identity was y over x. Right? All coming back to you. And then we had the secant of t, and we said that that was 1 over x. Right? The cosecant of t was 1 over y. And the cotangent, I'm going to squeeze that down a little bit. And the cotangent of t was x over y. Right? So we will be using like our trigonometric functions. This comes back to us over and over and over and over again through this whole entire trig chapter and trig kind of a semester in a sense. So these are the ones that we need to make sure that we really know, and we're going to keep referring back to them throughout the whole entire semester, right? So there's a relationship when it comes to these trig functions and how they correspond and how they relate to each other. So another good set of identities is called the reciprocal identities. So the reciprocal identities. I'm going to squeeze this up a little bit. So the reciprocal identities come in handy when we're trying to solve our problems. Instead of always having to go back, we can sit there and see that relationship on how some of these are equal to each other. So if we wanted to look at cosine of t, that is the same thing as 1 over secant of t. And we're going to get into a point of where we're going to go through our identities, and we're actually going to like simplify our identities or prove that one identity equals another identity. So, yep. So for example, like on this one, if we have, and I'm just going to write it over here, if we had the cosine of t, and we want to show or prove that that equals 1 over the secant of t. If we go back to our trigonometric functions, our cosine is x, right? Equals 1 over, and what's secant? 1 over x, right? 1 over x. So we can't leave a fraction over a fraction, so you'd have to simplify that.
Wait, where did you get the 1
from? From our reciprocal identity.
Oh.
Right, yeah, just showing how it actually works. Yep. So we can't leave a fraction over a fraction, so we're going to take our numerator and we're going to multiply that by our reciprocal of our denominator. And what's the reciprocal of 1 over x? X, right? So x equals x, right? So depending on the problem, sometimes it's helpful to write it one way, sometimes it's helpful to write it another way. And we're going to figure all those little guys out, right? So you got cosine has a reciprocal identity. All 6 of these have a reciprocal identity. So if we have the sine of t, anybody want to take a wild guess? 1 over, yep, cosecant of t. Yep. And the tangent of t is going to be 1 over the cotangent of t. Secant, the reciprocal identity for secant, what do you think it's going to be? 1 over cosine. Yep. Yep. Cosecant of t is going to be 1 over the sine of t. And what's the cotangent of t? The reciprocal identity is going to be 1 over the tangent of t. Yep, good job. So it takes some practice, but can we kind of see the connection between how those two are going back and forth? Right. And then there's just one, well, on a side note, there's also this one called the quotient identity. What's quotient mean? Is it division? Yeah. Yep. Oh, I can't spell today either. I can't spell any day. And it has to do with our tangent and our cotangent. When it comes to a tangent of t, you know how it's kind of like y over x? So this is the same thing as sine of t over cosine of t. And these ones, that one comes in handy a lot. And then if we think of the cotangent of t, so we know that tangent and cotangent, like 1 over, makes them the reciprocal, right? So if I wanted to figure out cotangent, what do you think it's going to be? Is it going to be sine over cosine, or do you think it's going to be...
Wait, why would tangent... I guess I'm just confused. So where did sine come from?
Right.
With tangent? Like,
If we go back up to our little trigonometric identities, right, and you look at the tangent is y over x, right? What's y?
oh, sine.
Yeah.
Oh,
What's x? Cosine. Yep.
thank you.
No problem. Yep. And when we look at our because remember there's this whole relationship, right? And it's the same thing if you think of just looking at secant. Secant is 1 over x. What could we put in place of x? Cosine t, right? Isn't that what we just rewrote it down here? But instead of having the x's and the y's, we actually have the trig in there. Not too bad? All right, so let's take a break from writing down all of our identities and try an example. So like we said, if we had our unit circle, right, and they gave us all of our pretty little points that are on the unit circle, but there's a whole bunch of other angles in between, and that circle is made up of a whole bunch of points. So we want to sit there and see if we can find some of the other points that are on our unit circle that aren't these perfect little 30 degrees, 45 degrees, or 60 degrees, right? So let's say, look at all the notes we take, right? Let's say we're going to find all 6 of the trigonometric functions. So we're going to find all 6 trig functions, because trig is fun. And let's say they gotta give us something. So they're gonna say that sine of t equals 2/5. And the cosine of t is, how about the square root of 21 over 5? So your 6 trig functions are sine, cosine, tangent, right? Secant, cosecant, and cotangent. So out of the 6, how many did I freely give to you as my gift to you? 2 of them, right? So really we only need to find 4 more, right? So we can do these in any order you want to do them in. So anybody got any ideas what they want to start off with? Tangent. I love tangent. Tangent's such a good guy. Mm-hmm. So the tangent of t, how could we write the tangent of t? Yeah, or sine over cosine. Yep. Sine of t over the cosine of t, right? And then we're just going to substitute it in. So what are we going to put in for sine of t? Yep, and we're going to divide that by square root of 21 over 5. Can't leave our friends like that, right? We don't want to have a fraction divided by a fraction. So what are we going to have? 2/5 multiplied by the reciprocal, 5 over the square root of 21, right? 5s are going to cancel each other out. So you get 2 over the square root of 21. Can we leave the radical in the denominator? No, some fancy mathematician got mad about that. So we're going to multiply by 1, but we're just going to write that as 21, square root of 21 over square root of 21. So we're going to have, what, 2 times the square root of 21 over 21, right? And my whole numbers, or my real numbers, my 2 over 21, those aren't going to reduce, so I am done with tangent. Okay. So look at it, we're halfway done. What do we want to go for next? Secant, sure. So secant of t, that would be, what's our secant going to be? 1 over cosine. So what do we get? 1 over cosine is the square root of 21 over 5. Okay. And so since it's that reciprocal identity, the secant is going to be the reciprocal, right? Or we can write it out, right? 1 times 5 over the square root of 21 equals 5 over the square root of 21. See how that's the reciprocal? It just flipped cosine right over, right? But we can't leave the radical in the denominator. Woo-hoo. So we're going to multiply top and bottom by the square root of 21. 5 times the square root of 21 over 21. And we can't reduce that guy any. So what about cosecant of t? That's going to be 1 over sine, right? So that would be what? 1 over 2 over 5. What's that going to give us?
5 over 2.
5 over 2, right? Then we got cotangent of t. Cotangent of t would be cosine t over sine of t. Or we know that cotangent is the reciprocal of what? Is that the reciprocal of tangent?
Oh, yeah.
Right? So we can either go up to our tangent and write the reciprocal, right? Or we can do our cosine over sine, like our fraction over our fraction. So what do you guys want to do?
Reciprocal.
Just do the reciprocal, right? So this is where, good answer, right? So then this is where, now you got a choice to make. You got to think about it. Like this is how we ended up having to finish out our tangent, because when we got to this point, why couldn't we stop here?
Oh, because it was in the bottom.
Right, because it was in the bottom, right? And then we had to multiply by the square root of 21. So I can either go from here, right? Because that would have been my answer except for that radical. And then I can do the reciprocal. So the reciprocal would be the square root of 21 over 2, right? But if you, however, if when doing your math, if you didn't write all of that out, and let's say this, you know, this is your final answer for tangent, and then you did the reciprocal from there. If you did the reciprocal from there, you'd have 21 over 2 times the square root of 21, right? Can't have a radical in the denominator, so you're going to multiply by the square root of 21, the square root of 21. So you're going to get 21 times the square root of 21 over 2 times 21, right? And then what happens to those 21s? They cancel out. Oop, why did that do that to me? And you're going to get the square root of 21 over 2, right? Little extra work, but same way. Yes?
So like, the denominator from tangent would, like, I guess you could call it like a rule. Would the rule be when you're like doing the cotangent, just get rid of the denominator and then like divide by whatever is in front, like to get the final answer of cotangent?
I think so.
Okay,
Yeah.
so I
No.
didn't.
Yeah. Yep. Yeah. Because it's ultimately, because when we got to tangent, like this is our final answer, right? It's just we couldn't leave it that way. So if anything, you're just going to backtrack to see like, okay, this is before when I finished the problem, before I became, you know, before I made some mathematician mad. So then from there, I can just flip it right over, right? Yep. Or you can go through and even, you know, because we know that it's cosine over sine, you could write cosine over sine and solve it that way too, right? All right. I think we got all 6. We got all 6.
So if they give you, like, say they didn't give you sine of t, or, yeah, sine of t and then cosine of t, and they gave you, like, 2 different ones, would that cover those other 2? Does that make sense? So you wouldn't solve for them, like, we just
Right.
did the other 4?
Yep. Like, technically, they could just give you one. Like, if they gave you, I'm just making this up, like, if I said the tangent of t equaled, I don't know, let's go with 3 over 4, right? So from there, you have your tangent solved.
So I have to find sine, cosine, secant, cosecant, and then
Right.
the other one?
Yep. And if you think about it, tangent is what over what?
Coming over, go,
Sine over cosine, right? So what's your sine going to be?
3,
What's your cosine going to be?
4,
Yep.
and then that would just be your answer?
Yep.
Would they ever give you, like, secant and cosecant for, like, your...
They could, but like if they did, if you had like say the secant of t equaled like 1 over, I don't know, well I guess I can't leave a square root in the denominator, can I? 1 over 7, right? Because I know that, right, it's 1 over cosine, then I can find my cosine. They won't give you like weird crazy ones.
Okay.
At least not right now. Maybe later. All right. We good with all of those little guys? All right. So there's one other set of identities we need to talk about, and they're called the Pythagorean identities. There's 3 of them. Right now we're going to focus on just one of them, and the other 2 come helpful later down the road, so we're just going to put all 3 of them up here. We'll put a star next to the most important one. And then in the future, we'll be like, hey, remember when we talked about the Pythagorean identities and we said that there were 3? This is how the other 2 help us out. So Pythagorean identities. And everybody remembers Pythagorean, right? Pythagoras. What a cool dude. Why am I having a hard time today? All right. So let's see if we can do a little backflash. This guy is a
Square.
circle, right? That's called the radius, right? And if I say that my radius is 1, I know that I'm talking about a unit circle. This little guy right here is a point, and we label our points with the coordinates x and y, right? All right, flashback time. Anybody remember how to find the equation of a circle? Some squares going on in there. What about x squared plus y squared equals r squared? Kind of like Pythagorean theorem. Yep, that's where it comes from. So on our unit circle, what could we fill in? The r, right? Because we know in a unit circle, our radius is always 1. So we can go with a little x squared plus y squared equals 1 squared, and 1 squared is 1, right? So now we have equation for our nice little unit circle. And then now we want to be able to take our trigonometric identities and be able to apply it to our unit circle. And what do we know about x in our unit circle? Yeah, x is our cosine. And what was the other variable we had in our equation? Y. And y is sine. So when it comes to our Pythagorean identity, instead of writing x, because we want to talk about some trig functions, we can write in cosine, right? So cosine squared of t plus the sine squared of t is going to equal 1. So that's our Pythagorean identity that we are really going to focus on. That's the one that we use the most. So we're going to put a nice little star next to that one. And then the other 2, we're just going to put up there so that it's in your notes. And then in the future, I mean, like I said, we're going to get to them. And then I'll be like, hey, remember when I wrote all of those up there? And then you'll be like, oh, yeah. I don't remember. So we have 1 plus tangent squared of t equals secant squared of t. Remember how I said there's this relationship between all of these? And then 1 plus cotangent of t equals cosecant squared of t. All right, we good? Ready for a fancy example? So on the previous little part, when we were looking at all 6 of these, like on this one, I gave you sine and cosine. Or if we talked about when they gave you tangent, from tangent you can still figure out sine and cosine. So you can always, that cosine and sine are like your x's and your y's. So once you figured out your x and y's, all of those other ones, I mean, that's the root of everything, right? Once you find x and y, you can fill in all of that stuff. But what happens when they don't give us both x and y? What are we going to do? We got to find the other one, right? We got to go on an adventure. So that's when our Pythagorean identity, like I said, we're just going to focus on that cosine squared plus sine squared equals 1 identity. That's where that little guy is going to come in handy, because I can give you either the x or the y, or I can give you the sine or the cosine, and you can figure out the other one using the identity. So let's go find cosine. So we're going to find cosine of t. If sine of t equals 3/5, and we're going to put a little stipulation on our t, our angle, or our radian. We're going to say that's between 0 is less than or equal to t, which is less than or equal to pi over 2. You're like, that is just too much for me, right? But it's all right, we're going to talk about this, right? You ready? All right. So when they want us to find cosine of t, and they only gave us sine, so they ultimately, on our unit circle, they gave us the y value, and we're looking for the x value, right? And my y value, 3/5, that's a positive value, right? So if I go back to my unit circle, remember I told you to keep your unit circle with you? If we looked around on the points that we don't have any 3/5 for our y values, right? But on our unit circle, which quadrants would we find y equaling 3/5? 1. Any place else? So y is positive. Where else is y positive? Quadrant 2, right? So when they give us that our sine is 3/5, we know it's going to be in one of these two quadrants. But we got to figure out which one of those two that it's in, right? So we need to figure out if our x has got to be positive or our x has got to be negative. And that's that last little piece. This little guy, right? This is saying that whatever angle or that radian that we're looking at, it has to be between 0 and pi over 2. Do you think we could find 0 and pi over 2 on our unit circle? Yeah. Whoop. Where's 0 and pi over 2? 1, right? So we're looking for our answer that's in quadrant 1, right? So our x has got to be positive and our y has to be positive, right? And our y is positive because they gave it to us. So we just have to make sure when we get done with our answer that our x is positive. Sound good? You following me so far? I didn't lose anybody on the trail, did I? All right. So since they only gave us that one identity, we know that we're going to use the Pythagorean identity. Right? So we're going to use cosine squared of t plus sine squared of t equals 1. Okay. Do we know anything about cosine squared of t? Any value to put in there? No, so we're just going to leave it as cosine squared of t. Plus, do we know anything about sine? It's 3/5, yeah? And what do we have to do to that 3/5? We got to square it. And all that still equals 1. Right? So what do we have? We got cosine squared of t plus, what's 3/5 squared? 9 over 25, yep. Sharing is caring, right? We got to make sure that when we are squaring these, both of those guys get squared, right? And we still equal 1. we're working on getting that cosine all by itself. So we want to get rid of the 9/25. So we're going to subtract that from both sides. Cosine squared of t equals 1 minus 9/25. How do we subtract 1 minus 9/25?
25 minus 9.
Yeah, find a common denominator, right? So we got cosine squared of t equals 25/25 minus 9/25. So cosine squared of t, 25 minus 9 is
16.
16. Right. Easiest way to do that, the way, like, I make numbers work for me. I call them like easy numbers, like 5s and 10s. So I always go like 25 minus 10, which would be 15. But I took one too many, so I got to put it back and then get to 16. Right? Make your numbers work for you. And then my denominator's still 25. Right? So right now I have cosine squared, but what do I need to find? Just cosine. So what do I have to get rid of? I got to get rid of the square. So to get rid of the square, what am I going to do? Square root both sides, right? Cosine squared of t equals, and I'm just going to put the whole thing under there. I'm going to slide this up a little bit for you guys. All right. What do you think the square root of cosine squared is? Cosine, right, of t. What's the square root of 16/25? What kind of 4/5?
Positive or negative?
Positive or negative. Yep. Positive or negative 4/5, right? But how many answers do we need? We're just looking for one of those. Which one are we looking for? The positive, right? That's where that little last piece about where our t was between 0 and pi/2 comes into handy. So we want our cosine to t to equal 4/5. So then on our unit circle, right, we would be going over 3/5 and up 4/5 to find our little point that would be on the circle.